In this video, at about 7 minutes something, we see this relationship pop up. Now, in the introduction to CODAP video, I didn't talk about it too much. I just sort of said it was a thing. Well, what we're going to do today is work with it. So you can see over in my Word document here, I've just copied out what that information is. So it's exactly the same as what we're seeing on the screen there. Sometimes you do need to expand the screen. So this graph here horizontally for it all to fit, particularly if you've got longer words here. So what we're seeing is the arm span in centimeters is 1.017 times the height in centimeters plus 6, and r squared is equal to 0.357. We're going to use this equation and this value to make some conclusions and to do some maths. So what we can do here is first of all, let's just simplify what we're seeing. So instead of writing our equation in terms of arm span and height, let's simplify it down a little bit, just so we're not writing as much. It's particularly important if you've got a really long variable name. So we're going to write y is equal to 1.017 times x plus 6, and that's just rewriting this equation here in terms of the y variable arm span and the x variable height. This equation is the equation of this line through here that has appeared when you click on Measure Least Squares line. Now, what we did in this video, if you've watched it, you noticed that I deleted some of the values, like I've got some outliers here, assuming this is a valid thing to do. Let's just see what happens when we do that. So that's sort of about here-ish, a little bit more. There we go. So we've got our equation here. Arm span is equal to 1.01 times the height. So 1.101 times the height minus, that's a 17 back there. We've also seen a change in the r squared value. What r squared is telling us is how well this line fits the data. The closer this value for r squared is to 1, the better the fit is. And when you look at, say, the Olympic sprinting time data, you'll see a value very, very close to 1, and you'll see that the line of best fit basically goes through all of those points. Here we have a little bit of scatter. Now, it is important to have a look at what our x values are. Looking at our possible x values, I'm just looking at the x-axis down here. It looks like our lowest value is 156, and our highest value might be 189. I'm calling out 155 to 190 just to round those numbers. Obviously, we're not going to round those numbers too much, but this is an important thing to consider when we're making some predictions using this equation, because if we're predicting values within our range of x values, we're going to be a little bit more confident in those compared to if we're predicting far away. We don't know what's happening to the data out here. Maybe it swings up, maybe it swings down, and maybe it continues. Who knows? We don't. So we can't draw any conclusions there. Now, I told you to open up the PowerPoint. What I'm looking at here is particularly the second slide. So this second slide gives me a really useful table in order to interpret our values for r squared and to interpret our predictions. So let's just look at these first two columns here. We initially had an r squared of 0.357. That is between 0.1 and 0.5. So that's actually a pretty weak correlation. A weak correlation or a weak relationship, we're going to be much less confident about those predictions that we make. When we removed the outliers, and again, we only remove outliers if there's genuine reason to, our R-squared value became 0.804. So now all of a sudden we're in this row here, we're between 0.5 and 0.9. So it's a moderate strength. And that has an impact on how confident we are in our predictions, depending on whether we're predicting a value based on X being inside the range of data. So in this case, between 155 and 190, or if we're extrapolating, where X is outside the range of data. So how do we do this? Let's have a look. Let's pick a value. I'm picking the number 180. Now, you may notice if you look closely, there is a value for 180 in our data. I don't care about that specific value though. What I'm trying to do is work out what this line predicts someone's height should be when they are 180. So it predicts what their arm span when their height is 180. Notice how pretty close to 180, 181 is below the line, 180 itself is above the line. So, you know, I guess the value is going to be in between those two values, and that's perfectly fine. All right, we are making predictions. We're not discussing the actual data points itself. So this is what we call interpolation. X is 180. That is between 155 and 190. I chose that value. So when you do this, you get to choose a value. What values seem interesting to you? I'm going to come back to the Olympic sprinting data. There's quite a gap. There's I think there's like a 1500 meter run, and then there's the marathon or something kind of like that. And there's a huge gap between those two. What if we had a race where the distance they were running was 5 kilometers? What would that winning time be? And, you know, if I'm planning an event, maybe if I'm planning the Olympics, that'd be a lot of fun. That number would be something I need to know in terms of actually planning the times for that particular race. How long are we going to need? So how do we do this interpolation? We've chosen a value 180. It's interpolation because 180 is between these two numbers. All we do is we substitute it in for X. Okay, this is our the equation that I'm choosing to use. I could have chosen to use the equation before I removed the outliers. It doesn't make a difference really in order to the process. The process is the same. And if there's no valid reason to remove the outliers, I have to use this one. So all I do is I write this equation out, but instead of X, I write the value I've chosen for X, 180. And then I just evaluate that. So this tells me that if someone is 180 centimeters tall, according to this model and this data, I would expect their arm span to be 181.18 centimeters. Now here's where we get to doing some interpretation. Someone's 181 centimeters tall. I predict their arm span will be 181.18 centimeters. Now, here's where we need to qualify this a little bit, and this is where we get to our table here. So I've done an interpolation. X was inside the range of the data, and I found Y. But R squared is 0.804, right? That value there. So I'm only making this prediction with moderate confidence. All right, and that's it. Let's do another option here. So that's just saying they're moderate correlation, so we're moderately confident about that data. We're now going to try an extrapolation, and the process is exactly the same, but I'm going to choose a different value for X. I'm going to choose a value of 200. If I look at my data, 200 is beyond my highest value of 190. I can't even see it in this set of axes, but I don't have any data up there. I don't know what it's going to do. So I can do the mathematics of it, right? I just substitute in 200 for x, right? Same thing, subbing it in for x up here and evaluating that 1.101 times 200 minus 17. That means that I would expect that someone who is 200 centimeters tall, but if someone is 200 centimeters tall, I predict that their arm span will be 203.2 centimeters. And then I look at the confidence. We are still in a moderate level of confidence here. R squared is still 0.8, but now we're doing an extrapolation, and we do need to consider whether we're extrapolating near the data or far from the data. So if I was extrapolating out to 1,000 centimeters tall, right? One person is that tall. That's a really far extrapolation. 200 is pretty close. It's only a little bit above the data itself, so we're a little bit more confident about that than the far extrapolation, but not a lot. So what am I predicting there? That's a near extrapolation, so with low confidence. And just what that sentence is meaning with low confidence, that just means numerically the value is 203.2 centimeters. But I'm not going to be surprised if I find someone who is 200 centimeters tall and it turns out their arm span is something different. Okay, that's what you're doing. What I would like you to do is have a look at the instructions on the Redo Connect and have a go working through the data sets that you looked at yesterday. And when I come back, we'll compare some notes.